Now the characteristics of the groups and the periods in the periodic table can be understood by comparing the properties of the elements. When you compare the properties of the elements of this periodic table, you come to know the characteristics of groups and periods. Now if you see the chemical properties in a group, when you go from top to bottom in a group is always this way. So when you go from top to bottom in a group, they show similarity and gradation in their properties. So the properties are very similar and gradation is also very similar. When you go from left to right, that is in a period, when you go, this is a period, this way is a period. So when you go from left to right in a period, then they slowly change. The properties of the elements slowly change from one end to the other end. That is from left to right, the properties changes slightly from one end to the other end. That is in group there is similarity in properties, and in period the properties slightly keeps on changing. Within a period the neighboring elements differ slightly in their properties. So difference between the properties of the neighboring elements is very small or very slight. But when you compare the first element and the last element, there is a vast difference in their properties. So distant element differ widely in their properties. So if you take a distant element, they differ widely in their properties, but the neighboring element shows a very slight variation in their properties. Now uranium, that is over here, uranium, whose atomic number is 92. After uranium, that is from 93 till 118. Over here you can see from 93 till 103. Then 104 is here, 104 till 118. So all this element after uranium from 93 till 118 are all man-made, and all these elements are radioactive and unstable and has a very short life. Now another important thing is what? This group 1. Group 1 is known as alkali metals. Group 2 is known as alkaline earth metal, and from group 3 to group 12, that is D block element, is also known as transition elements, and from group 13 to group 18, that is the P block element, they are known as normal elements, and the F block element, that is a lanthanide series and the actinide series, are known as inner transition elements. So remember, ग्रुप 1 को क्या बोलता है? एल्कली मेटल्स. ग्रुप 2 को क्या बोलता है? एल्कलाइन अर्थ मेटल. ग्रुप 3 से ग्रुप 12 दैट इज डी ब्लॉक एलिमेंट्स को क्या बोलता है? ट्रांजिशन एलिमेंट. और 13 से लेके 18, ग्रुप 13 से लेके ग्रुप 18 दैट इज पी ब्लॉक, उसको क्या बोलता है? नॉर्मल एलिमेंट्स. और जो लैंथेनाइड और एक्टिनाइड सीरीज है, एफ ब्लॉक एलिमेंट्स है, उसको क्या बोलता है? इनर ट्रांजिशन एलिमेंट्स. Now on page number 22 there are some questions. The first question is, go through the modern periodic table. The periodic table is given, that is table number 2.7 on page 23. On the top it is given, and write the names one below the other of the elements of group 1. So I have written all the names of the element one below the other of group 1. Group 1 is also known as alkali metals. So it is also known as alkali metals. Now write the electronic configuration of the first 4 elements in this group. So the first 4 elements electronic configuration, they have asked to write down the first electronic configuration of the first 4 elements. Now electronic configuration can be easily written with the help of the atomic number, which is given on the top, that is 1, 3, 11 and so on. Now what is the atomic number of hydrogen? Of hydrogen is what? 1. So the electronic configuration is what? Only 1, because in the first shell only 2 electrons can be accommodated and hydrogen is having only 1, so 1 electron is put in the first shell. तो एटॉमिक नंबर पता रहेगा कोई भी एलिमेंट का, तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखना बहुत इजी पड़ेगा. तो हाइड्रोजन का एटॉमिक नंबर का क्या है? 1. तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या रहेगा? 1, क्योंकि पहला शेल में सिर्फ 2 इलेक्ट्रॉन रखा जा सकता है, इसके पास सिर्फ 1 है, तो इसलिए 1 फर्स्ट शेल में आएगा. और नेक्स्ट वन जैसा लिथियम है, व्हाट इज़ द एटॉमिक नंबर ऑफ लिथियम? लिथियम इज़ 3. So how will you write down the electronic configuration? लिथियम का एटॉमिक नंबर 3 है, तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन कैसा लिखा जाएगा? मैंने पहले बोला था कि फर्स्ट शेल में सिर्फ 2 इलेक्ट्रॉन रखा जाता है, तो 2 आएगा. तो टोटल नंबर ऑफ इलेक्ट्रॉन इसके पास 3 है, तो 2 ही लिखा है, तो कॉमा डाल के एक जो बचा है वो नेक्स्ट शेल में चला जाएगा. नेक्स्ट वन, एटॉमिक नंबर ऑफ सोडियम. What is atomic number of sodium? That is 11. So how will you write down the electronic configuration? Sodium का atomic number 11 है, तो electronic configuration कैसे लिखेंगे? पहला शेल में 2, फिर सेकेंड शेल में सिर्फ 8 ही रखा जा सकता है, उससे ज़्यादा नहीं. So in the second shell you can place only 8 electron, not more than 8 electron. Now it is having 11 electrons. Total you have written how much? 8 plus 2, 10. One more is remaining, so that will go in the third shell. Now next one, potassium. Potassium is having how many? What is the atomic number? 19. So how many electrons it is having? 19 electrons it is having. Now what is the electronic configuration of this? In the first shell 2, in the next shell 8, and in the third shell also you can accommodate only 8 electron. तो तीसरा शेल में भी सिर्फ 8 ही इलेक्ट्रॉन रखा जा सकता है. अभी ऐड करके देखो, 8 + 8 16 + 2 18, मगर ये 19 है तो और एक आएगा. सो इट विल गो इन द फोर्थ शेल. So this is how the electronic configuration is written with the help of the atomic number of that element. तो atomic number पता होगा तो electronic configuration लिखना बहुत आसान है. तो अगर उन लोग electronic configuration लिखने बोलेगा तो atomic number पता रहना चाहिए. उसका भी मैं sentence सिखा के दूंगी कि कैसे याद रखने का. Now which similarity do you find in their configuration? तो क्या similarity दिखाई देता है? हर एक में लास्ट में कितना नंबर है? 1 1 1 1. तो ये लास्ट शेल में जो इलेक्ट्रॉन्स रहता है, ये लास्ट शेल में कितना इलेक्ट्रॉन है? 1. इसमें भी 1 है. तो लास्ट शेल में जो इलेक्ट्रॉन रहता है उसको बोलता है वैलेंस इलेक्ट्रॉन. सो दे हैव सेम वैलेंस इलेक्ट्रॉन. they have same valence electron. So if you see in each of the every element, the last shell is having only one, that is valence electron is 1 1 1 1. So what is valence? Valence electron का मतलब क्या है? जो लास्ट शेल में जितना इलेक्ट्रॉन्स रहता है उसको बोलता है वैलेंस इलेक्ट्रॉन. अभी इसमें चारों में देखा जाएगा तो सब में 1 ही है. लास्ट शेल में 1 है, इसमें भी 1 है, इसमें भी 1 है और इसमें भी 1 है. सो दे हैव सेम वैलेंस इलेक्ट्रॉन. कितना वैलेंस? नेक्स्ट क्वेश्चन, हाउ मेनी वैलेंस इलेक्ट्रॉन्स आर देयर इन ईच ऑफ दिस एलिमेंट? हर वैलेंस इलेक्ट्रॉन कितना है? 1 1 1 1. मतलब लास्ट शेल में कितना इलेक्ट्रॉन है? सब में 1 ही है. सो दे हैव 1 वैलेंस इलेक्ट्रॉन in each of these elements. In each of these elements. Now how to draw this? Supposing for hydrogen, this is a nucleus. So only one shell it is having with 1 valence electron because that is the last shell of hydrogen. Now lithium, nucleus. In the first shell 2 electron over here. Lithium 3. In the first shell 2. In the next shell it will be having 1 electron. It will be having only 1 electron. Next one, sodium. In the first shell 2 electrons. In the second shell 8 electron, 1 2 3 4 5 6 7 8. Over here 2 electron, then 8 electron, then 1 electron. So the valence electron or the electrons in the last shell is how much? 1. Next, potassium. This is a nucleus. In the first shell 2 electrons. In the next shell 8 electrons. So 2 8. The next shell also 8 electrons are there. Eight electrons and one more is there, that is 1. So 1 electron is there in the last shell. So valence electron in each of this. This is also valence electron 1. This is also 1. This is also 1. This is also 1. So they have 1 valence electron in each of these elements. Now when you go from top to bottom, you will see the number of shells goes on increasing. It is having only one shell, this is having two shells, this is having three shells, and this is having four shells. So the number of shells goes on increasing as we go one below the other. In group 1, what is a valence electron? Only one valence electron is there in the group. This way also you can write down the electronic configuration, and drawing is this way. So electronic configuration in drawing form will be this way. Now I had already said with the help of the atomic number you can write the electronic configuration. This one, group 1, that is alkali metal, I had already shown. Hydrogen is 1, so electronic configuration is 1. Lithium is 3, so electronic configuration is 2 and 1. And sodium is 11, so it will be 2, 8, 1. And potassium is 19, that is 2, 8, 8, 1. In the first shell only 2 electrons are there. In the second shell it can accommodate 8 electrons. In the next shell 8 electrons, and in the last shell the remaining electrons will go. So if you see in the group 1, the valence electrons are same. Now we will see the group 2, that is beryllium. What is the atomic number of beryllium? 4. So in the first shell 2, and how many is remaining? 2 is remaining, so the next shell also it will be 2. So electronic configuration of beryllium is 2, 2. Magnesium is 12, so first shell 2 electrons, next one 8, then next one 2. Calcium 20 is there, so 2, 8, 8 and 2. So even in this group 2 you will see the valence electron. The valence electron is same, 2, 2, 2. The electron which is there in the last shell is same. Over here it was 1, 1, 1, 1. So valence electron over here is 1. Now if you see the halogens, it comes under group 17. Halogens are fluorine, chlorine, bromine and iodine. So we have written only till chlorine because this year you are having only till calcium. You have to study, not rest of the elements, because the arrangement of electron is still more complicated. So only the basic has been taught over here. So fluorine, it is 9. So how many electrons it will be having? 2 and 7. 2 and 7. 7 plus 2, 9. Chlorine is having 17. So electronic configuration is 2, 8 and 7. So here also if you see group 17, the valence electron is same, that is 7. So what is a characteristic of a group? Electronic configuration of valence electron. The electronic configuration of the valence electron, that is the last shell electron, is known as valence electron, is the characteristic of group. So if you see this table, you come to know that the valence electron in each group, in the first group the valence electron was same, that is 1. In group 2 the valence electron was same, that is 2. And in group 17 also the valence electron is same, that is 7. Now second group is known as alkaline earth metal, and halogens are what? Fluorine, chlorine, bromine and iodine. I have shown only till chlorine because this year you have to study only till calcium, the atomic number. How to remember the atomic number of all the elements up to calcium? So this is a sentence: Hi Henry, little Benny boy, caught naughty Ozzy fighting Nelly Nana. Write down the sentence, it will become easier. By heart this sentence, write it down in your notebook and by heart this sentence also. It will be more convenient if you write it in the textbook, so it will be easily visible to you while studying. So, hi Henry, little Benny boy, caught naughty Ozzy fighting Nelly Nana is the first sentence. Next one is magnesium always sings pop songs. The next one is clothes are kept casual. Now how to remember? Over here the first letter is H. So H is what? Hydrogen. Next one is He, that is helium. Next one is Li, that is lithium. Next one is Be, that is beryllium. Next one is B, that is boron. C, that is carbon. N, that is nitrogen. O is oxygen. F is fluorine, Ne is neon, Na is sodium. The next sentence, Mg is magnesium, Al is aluminum, Si is silicon, P is phosphorus, and S is sulfur. Next one, clothes are kept casual. So Cl is chlorine, Ar is argon, K is potassium, and Ca is calcium. So the first, supposing if I want to see, this is what boron. So what is the atomic number of boron? 1, 2, 3, 4, 5. So atomic number of boron is 5. If I want to see sodium, we know already sodium is 11. So just count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So by remembering this sentence, it is very easy which are the elements present in the serial order, and you can also find out the atomic number just by counting the according to the series. So this way you can remember the elements, name of the elements as well as the atomic number. So you write down the sentence in your textbook and by heart it. It's important that you know the atomic number till calcium. So it will be easy for you to find out the atomic number also, and the symbol of the element also, and the name of the element also. If you know the atomic number, it is easy to write down the electronic configuration also. Now this was about group. Now we will be studying about the periods. Now periods and electronic configuration. These are the questions which are given on page number 23. So it is given in page number 23. Now in the modern periodic table, which are the elements in the period 2? Now we should know that period is going this way, horizontal row it is in period, and columns comes in group. So in group we have column, and in period we write the elements in horizontal row. So what are the elements in period 2? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Now what is the atomic number of this? 3. Lithium is 3. So what is the electronic configuration? Electronic configuration is 2 and 1. Now what about beryllium? It is 4. So it is 2, 2. What is of boron? That is 5. That is 2, 3. Carbon is 6. So it will be 2, 4. And nitrogen is 7. So it will be 2, 5. And oxygen is 8, so it will be 2, 6. Fluorine is 9, so 2, 7. And that of neon is how much? 2, 8. So this is the electronic configuration of the period 2. Now they have asked, is the number of valence electrons same? Are the valence electrons same? No, over here it is 1, here it is 2, here it is 3, here it is 4, here it is 5. And here it is 6, 7 and 8. So is the valence electrons, number of valence electrons same? No, they are not same. So the valence electron is not same. So is the number of shells same? Now let us draw this. This is a nucleus. Now how many shells it will be having? Only 2 shells. In the first shell 2 electrons are there. And in the next shell only 1 electrons are there. Now in the first shell 2 electrons are there, and in the next shell 2 electrons are there. Now next one, 2, 3. In the first shell 2 electrons, and the remaining 3 electrons are there in the next shell. Now next one, 2, 4. In the first shell 2 electrons are there, and in the next shell 4 electrons are there. 1, 2, 3 and 4. Next one, 2, 5. So in the first shell 2 electrons are there, and in the next shell 5 electrons are there. 1, 2, 3, 4 and 5. Next one, first shell 2 electrons, and in the next shell 1, 2, 3, 4, 5, 6, only 6 are there. Next one, 2, 7. So in the first shell 2 electrons are there, and in the next shell 7 electrons are there. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 and 7. Next one, neon. 2 shells are there, 1 2 in the two electrons in the first shell, and in the next shell 8 electrons are there, 1 2 3 4 5 6 7 8. So if you see the number of shells in all these elements, when you go in a period from left to right, how many shells are there? Same number of shells. Here also 2, here also 2, here also 2, here also 2, and so on. How many electrons can the second shell accommodate? 8 electrons. So till 8 electrons it can accommodate, and in the first shell only 2 electrons can be accommodated. So if you see, the number of shells are same in a period. So is the number of shells same? Yes, it is same. Is the number of valence electrons same? No, the valence electrons are all different. It is going one after the other serially. 1, 2, 3, 4. So it is going on increasing one at a time. The number of valence electron is going on increasing one at a time. Now when what is a characteristic? That means what is a characteristic of a period? The number of valence electron is not same, but the number of shells is same. So the number of shells is same and the number of valence electron is not same in a period. Now we had discussed about group. In group, if you see, the number of valence electron is same. The number of valence electron is 1, 1, 1 and 1. What is valence electron? The electron in the last shell. And if you see, the number of shells are going on increasing. Here it is only 1, here it is 2, here it is 3, here it is 4. So here number of valence electron was same. Was same in group, and over here number of valence electron is not same in a period. Here the number of shells is same. But here the number of shell goes on increasing. तो ये पीरियड के बारे में है. अभी पीरियड क्या होता है? हॉरिजॉन्टल रो को पीरियड बोलता है और वर्टिकल कॉलम को ग्रुप बोलता है. तो इन पीरियड 2 का एलिमेंट्स को अरेंज करने बोला. तो पीरियड 2 का एलिमेंट्स क्या है? लिथियम, बेरिलियम, बोरॉन, कार्बन, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, नियॉन. और उसका एटॉमिक नंबर क्या है? 3, 4, 5, 6, 7, 8, 9, 10. अभी इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है? 2, 1. इसका क्या है? बेरिलियम का 2, 2. बोरॉन का 5 है तो 2, 3, 2, 4. ऐसा एक एक इंक्रीज. तो वैलेंस इलेक्ट्रॉन देखा जाए तो किसी का भी सेम पीरियड में, एक ही पीरियड में सेम नहीं रहता है. पहला वाला का 1 है, फिर 2 है, फिर 3 है. तो नंबर ऑफ वैलेंस इलेक्ट्रॉन इज इंक्रीजिंग, मतलब बढ़ते ही जा रहा है एक के बाद एक. और नंबर ऑफ शेल्स बढ़ रहा है नहीं, सब में 2 ही शेल्स है. तो 2 ही शेल्स है in a period. So number of shells are same and number of valence electron is not same in a period. लेकिन ग्रुप में ऐसा नहीं था जो आपने पहले डिस्कस किया था. इसमें नंबर ऑफ वैलेंस इलेक्ट्रॉन सेम रहता है और शेल्स जो रहता है वो सेम नहीं रहता है, वो एक एक करके बढ़ते जाते हैं. पहला में 1 था, फिर 2, फिर 3, फिर 4. तो नंबर ऑफ वैलेंस इलेक्ट्रॉन was same in a group but the number of shells goes on increasing. Now in period 2, the number of electron goes on increasing. That is number of valence electron, not electron. Number of valence electron goes on increasing one at a time. First it was 1, then 2, then 3, then 4. How many shells are there in this period 2? All the elements are having only 2 shells. Now if you see in the period 1, here the atomic number of hydrogen is 1, so there is only 1 shell with 1 electron in it. Helium is having 2 atomic number, so there is only 1 shell with 2 electrons in that particular shell, because the first shell near the nucleus can accommodate only 2 electrons. So what you see over here, that in period 1, number of the period is 1. It is having only one shell. Over here the period 2, it is having only 2 shells. Now in period 3 also, if you see, now sodium is 11. So what is the electronic configuration? 2, 8 and 1. So it is having 2 electrons, 8 electrons and 1 electron in its outermost shell. So the period is what? 3, and how many shells are there? 3 shells. If you see magnesium also, this is nucleus, 12 it is. So what is the electronic configuration? 2, 8, 2. So in the first shell it is having only 2 electrons. In the next shell it is having how many electrons? 8 electrons. And in the last shell it is having how many valence electron? 2 valence electrons. So here also the number of shells is 3. Here also number of shells is 3. If you see aluminum also, the first, what is the electronic configuration? 2, 8, 3. So number of electron in the first shell is 2. Next one is 8, 3, 4, 5, 6, 7, 8. And in the last shell it is having 3 electron, 1, 2 and 3 electron. So how many shells it is having? Only 3 shells. Now silicon also same way. First shell 2 electrons, next shell 1, 2, 3, 4, 5, 6, 7, 8, and in the last shell it is having 4 electrons. So how many shells it is having? 3 shells. So if you go on, if you compare all these elements, all will be having 3 shells, and the number of valence electron increases 1 at a time. First it is 1, then 2, then 3, then 4. This will be how much? 2, 8, 5. So valence electron is how much? 5. This will be how much? 2, 8, 6. So the valence electron is how much? 6. This will be 2, 8, 7. The valence electron is how much? 7. And this will be 2, 8, 2. The valence 2, 8, 8. So the valence electron is how much? 8. So the last shell is having one valence electron, which is increasing 1 at a time. So in period 1, how many shells are there? Only 1. In period 2, how many shells are there? 2 shells are there. And in period 3, how many shells are there? 1, 2 and 3 shells. Here also you can see in the electronic configuration 1, 2 and 3. 1, 2 and 3. So all are having only 3 shells. In group, the shells goes on increasing 1 at a time, and in period the valence electron goes on increasing 1 at a time. But over here in group the valence electron remains the same. So here it is what? 2, 2. So the valence electron is how much? 2. Group is what? 2. In magnesium it is 12. So 2, 8, 2. So what is the valence electron? 2. In calcium it is 2, 8, 8, 2. So what's the valence electron? 2. So in group the valence electron is same, and in periods depending upon the number, here it is 1, so the valence electron is 1. Group 2, the valence electron is 2. So from the electronic configuration you get lots of information about the elements. Now number of elements present in the first, second and third period depends upon the electron holding capacity of the shell. Now the first shell is known as 1, is numbered as 1, second one, and this is the third one, and this is the fourth one. Over here the first one is the one which is nearest to the nucleus. In the nucleus there are neutrons and proton. The shell nearest the nucleus is K shell. The second shell is known as L. The third shell, which is in blue color, is known as M. And the outer shell, which is in black, that is known as N. So K is the first shell, L is the second shell, M is the third shell, and N is the fourth shell. To find out the electron holding capacity depends upon this formula, 2n square. Over here N is what? 1 square. When you multiply by 2 you get what? 1 into 1, 1. 1 into 2 is how much? 2 electrons. The second one, that is 2 square into 2. 2 square is how much? 4. 4 into 2 is how much? 8. The third one, 3 square. that is 9. 9 into 2 is how much? 18. Then 4 square, that is 16. 16 into 2 is how much? 32. So the first shell can hold 2 electrons, the second shell can hold 8 electrons, and the third shell can hold 18 electrons, and the fourth shell can hold 32 electrons. So the number of elements in the first, second and third depends upon the electron capacity of that particular shell. For K shell, how many electrons it can hold? 2 electrons. So you can see in the first period there are only 2 elements. In the second shell it can hold 8 electrons. So in the second period there are 8 elements, 1, 2, 3, 4, 5, 6, 7 and 8. And in the third shell there are 18 electrons, but in the third period instead of 18 elements there are only 8 elements, 1, 2, 3, 4, 5, 6, 7, 8. Why? Because it also depends because of the law of electron octet. There are many other factors. After the third period, there are other factors which determines the filling of electrons in that particular shell. So this year you will be having only till calcium. So first, second and third you remember. Fourth one, there are other factors which you will be studying in the next standard. So this year you won't be having that. So law of electron octet. So the first shell is known as K, second shell is known as L, third shell is known as M, and the fourth shell is known as N. Now the chemical properties. The chemical properties of these elements depends upon valence electron and also depends upon the shell number of valence shell. Now what is the meaning of that? So the chemical property depends upon two things. What is that? Valence electron and the shell number of the valence shell. What is the meaning of valence shell? The valence electron is present in which shell? The valence shell is always the outermost shell of that particular element, and the number of electron which is present in the outermost shell is known as valence electron. तो chemical properties दो चीज़ के ऊपर depend करता है, एक तो valence electron और दूसरा shell number of valence shell. तो valence electron, valence shell बोला तो क्या last shell को valence shell बोलता है of that particular element. जो element का जो last shell है उसको valence shell बोलता है, और जो electron वैलेंस शेल में रहता है उसको बोलता है वैलेंस इलेक्ट्रॉन. जैसे कि हाइड्रोजन का एटॉमिक नंबर 1 है तो इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है? 1. लिथियम का 3 है तो उसका एटॉमिक कॉन्फ़िगरेशन क्या है? 2 और 1. सोडियम का 11 है तो इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है? 2, 8 एंड 1. एंड पोटेशियम इज़ 19. सो व्हाट इज़ द इलेक्ट्रॉनिक कॉन्फ़िगरेशन? 2, 8, 8 एंड 2. नाउ एंड 2 नॉट 1. Now if you see over here the valence electron is 1, that which we had already discussed before. So the valence electron is 1 over here. Here the valence electron is in which valence shell? That is K shell, because it is having only one shell. Here there are 2 shells, so the valence electron is in which shell? L shell. Over here there are 3 shells, so the valence electron is in which shell? M shell. And over here the valence electron is in which one? The fourth one, that is the N shell. So it depends upon the valence electron as well as on the shell which it is present. So here it is present in the N shell, here it is present in the M shell, here it is present in the L shell, and here it is present in the K shell. Now next, after the lesson there are 2 fill-ups. So from the atomic number and the electronic configuration you get many information. The number of electron in the outermost shell of the alkali metal. These are the alkali metal. The group 1 is known as the alkali metal. So what is the valence electron shell of alkali metal? The number of electron in the outermost shell, how much it is? 1, 1, 1 and 1. So the answer is what? 1 over here. In which block of the modern periodic table are the non-metals found? I had told before the non-metals are found after the zigzag line. So these are the metalloids. So the one which is present on this side, on the right hand side of the zigzag, is known as non-metal, and this is which air block? P block. This was the S block. D block I have not shown over here. D block is between 3 to 12th group. So 3rd to 12th group I have not drawn over here. So from 3rd to 12th group is a D block element, and after the zigzag, which block elements are there? P block element. So answer is what? P block element. Now an element has its electronic configuration 282. Now I had told just now, from the electronic configuration you get many information. What is the atomic number of this particular element? You have to just add them. 2 plus 8, 10. 10 plus 2 is what? 12. So the atomic number is 12. What is the group? Which group it is present, that we have to find out. So which group it is present? See the valence electron. Valence electron is what? 2. So it is present in the group 2. To which period does this element belong? See how many shells are there? 1, 2, 3. 3 shells are there. So it belongs to period 3. So from the electronic configuration you get many information. The last electron which is present over here shows the group. So here it is 2. So the group is what? 2. How many shells are there? You can see the comma. So there are 3 shells, 1, 2 and 3. So the period is 3. Now with which of the following elements would this element resemble? So this element resemble to which of these following element? Does it resemble to nitrogen, beryllium, argon or Cl? You can write down, they have given the atomic number in the bracket. So write down the configuration. What is the configuration over here? 2 and 5. What is the configuration over here? 2, 2. This is what? 2, 8, 8. What is this? 2, 8, 7. So what is the valence electron over here? 7. Here it is what? 8. Here it is what? 5. And here it is what? 2. So which one is having 2 as a valence electron? That is beryllium. So this is the right answer, that is beryllium. So which element resembles which of the following element would this element resemble? So this element resemble to beryllium, that is atomic number with 4.